We are going to start now lecture 14 of chapter 10 class 11th mathematics, straight lines. In this lecture we will talk about some joint equations of the lines. So first we are saying we are given two equations. One is ax plus by plus c is equal to 0. This is one equation. Second is a1x plus b1y plus c1 is equal to 0. This is the second equation. Then the joint equation of these two lines, it is given by the product of these two values. We are saying it is ax plus by plus c into a1x plus b1y plus c1, that is equal to 0. This is called the joint equation. And conversely, if the equation is given in this form, then these are the two separate equations of the line. So as an example, we are saying these are the two equations. One is y is equal to x and second is y is equal to minus x. So the joint equation we have over here, it is y minus x into y plus x is equal to 0. So we get it is y square minus x square is equal to 0, or we can write it is x square minus y square is equal to 0. Next we have is the equation is given to us. It is given in the form, it is x square minus 6xy plus 8y square is equal to 0. This is the equation given to us, and it is being given that this is the joint equation of two lines. So we want to separate these two lines. So we are calculating the value of x from this equation. We get x is equal to 6y plus minus square root of, we have over here it is 36y square minus 32y square divided by whole divided by 2. So the equations we get from this, it is in the form x is equal to 3y plus minus y. So we are saying we have two equations now. One is x is equal to 3y plus y, that is 4y, and second is x is equal to 3y minus y is equal to 2y. So these are the two separate equations of the line corresponding to the joint equation x square minus 6xy plus 8y square is equal to 0. The next definition we have is the homogeneous equation in two variables. So we are given an equation of the form, we are talking about this equation. Now what is the property over here? We are saying if we look at the powers, look at this first term, the total power over here it is x raised to the power 0, y raised to the power n. So sum of both these terms it is n. Similarly for the next term, we have y raised to the power n minus 1 into x raised to the power 1. Sum of these two powers it is n. Similarly look at this last term, it is x raised to the power n, y raised to the power 0. The sum of both these powers it is n. So we are saying an equation of this form in which the sum of powers of x and y in every term is the same, that is n. These kind of equation, these are called the homogeneous equations of degree n. This is an homogeneous equation of degree n. So we are going to prove now that this kind of equation we are talking about, this kind of equation, it is basically the combined equation of n straight lines. This is a combined equation of n straight lines. So it means we have to separate all these equations. So we start with this term, it is a naught yn plus a1 yn minus 1 x plus so on up to plus a n x raised to the power n is equal to 0. This is the homogeneous equation that we have. Now if we divide this whole by x raised to the power n, we obtain it is a naught y by x raised to the power n plus a1 y by x raised to the power n minus 1 plus so on up to plus a n is equal to 0. So we are saying that we have divided all these terms with x raised to the power n, and now look at this equation. This term y by x is there, y by x is there, similarly y by x is over here, and it is of the form y by x raised to the power 0. So we are saying that this is an equation of degree n in y by x, and its roots, it will have some roots, and we are saying suppose its roots they are m1, m2, so on up to m n. So if these are the roots of this equation, it means you can write this equation in the form a naught y by x minus m1 into y by x minus m2, so on up to y by x minus m n, that is equal to 0. We can write it in the form this is equal to 0. So if we take the LCM over here, what we will obtain, it is of the form a naught into y minus m1x into y minus m2x, so on up to y minus mnx, that is equal to 0. So what we are obtaining from this is that this given equation, this given homogeneous equation we are talking about, we can write it as the product of y minus m1x, y minus m2x, then y minus so on up to y minus mnx. We can write it as the product of these terms, and these are basically the separate equations of the line. If we equate all these equal to 0, we can see that this is an equation of a line, this is equation of another line. So these are basically the required equations of the line. So we are saying that if we have the equation of the form ax square plus 2hxy plus by square is equal to 0, clearly this is a homogeneous equation of degree 2. Why degree 2? We are saying it is ax square plus 2h x raised to power 1 y raised to power 1 plus by square is equal to 0. So if we look at the powers over here, if we look at all these powers over here, all these powers, these are sum of these powers, it is 2. So this is a homogeneous equation. So we want to find the line, two lines whose joint equation is in this form. So to find the equation of the line, we are writing it is a plus 2hy by x plus by by x square equal to 0. If we substitute y by x is equal to m, we obtain this is bm square, not by square, it is bm square plus 2hm plus a is equal to 0. So if m1 and m2, these are the two roots, we are saying, if we are considering that m1 and m2 are the two roots, then we have m1 plus m2, that is equal to minus 2h by b, and m1 into m2 is equal to a by b, that is coefficient of x square by coefficient of y square. Now if we calculate the value of m1 and m2 from this equation, the quadratic equation in m, we get m is equal to minus 2h plus minus 2 square root h square minus a b by 2b, and m we are saying this is basically y by x that we have. So we obtain the value of y by x in this form. So we can obtain the required equations in this form, that y is equal to minus h plus square root of h minus abx, and similarly by is equal to minus h minus square root of h minus ab into x. So these are the two equations corresponding to this homogeneous joint equation, and it is clear from both these equations that these two equations that we are talking about, that is y is equal to m1x and y is equal to m2x, both these equations, they pass through the origin. So we are saying this is the joint equation of two lines. From this we can see that these are the two equations which pass through the origin. Now from these two equations we can clearly see that the lines we are talking about, they are real and distinct if h square minus ab is greater than 0, and the lines are coincident if h square minus ab is equal to 0, and lines are imaginary if h square minus ab is less than 0. These are the three conditions we have. Now next we have is the condition when the lines, they will pass through the origin. We are talking about this equation is given to us, and the corresponding equations that we have, they are in the form y is equal to m1x and y is equal to m2x. We are saying that the two lines, why we are having the equations in this form, we are saying the value of x intercepted is 0, that is these two lines, they are passing through the origin. Then we are talking about the case that ax square plus 2hxy plus by square, that should be equal to y minus m1x into y minus m2x. Now if we open these terms, we will obtain that the value of 2h that we will have, that is by comparing the coefficient, we will obtain that 2h is equal to minus b into m1 plus m2 and a is equal to b into m1 into m2. So from these conditions we are getting that m1 plus m2, that is equal to minus 2h by b, and m1 into m2 is equal to a by b. Now next we have is find the condition that the slope of the one of the lines represented by this combined equation should be n times the slope of the other. So we are given this equation, it is ax square plus 2hxy plus by square is equal to 0. We are saying, suppose it is representing two equations, y is equal to m1x, second is y is equal to m2x, and we know that the corresponding condition that we will have over here, it is that m1 plus m2 should be equal to minus 2h by b, and m1 into m2 is equal to a by b. Now from the given problem, it is being given that the slope of one is n times the other, so we are writing that m2 is equal to n times m1. If we substitute this value in these equations, we will obtain that we are talking about this equation over here, it is m1 plus n times m1 is equal to minus 2h by b. This implies us m1 is equal to minus 2h by b into 1 plus n. From the second equation, we are writing it is n times m1 square is equal to a by b. So we can write this is n is equal to, from this condition if we substitute the value of m1 over here, we are getting the answer as, from this condition we are writing it is n into 2h by b into 1 plus n, with minus sign over here, whole square, that is equal to a by b. And on solving this, we will obtain the final condition as 4nh square equal to ab into 1 plus n whole square. So this is the required condition when the two equations represented by this joint equation, the slope of one will be n times the slope of the other. Next is find the product of the length of the perpendiculars drawn from the point x1 y1 on the lines given by this combined equation. So again we are talking about the line ax square plus 2h xy plus by square is equal to 0, and suppose we are saying that it is representing the combined equation of two lines given by y is equal to m1x and y is equal to m2x. These are the two different equations. So from this condition we have m1 plus m2 is equal to minus 2h by b, and m1 into m2 is equal to a by b. The length of the perpendicular from x1 y1 on these lines are given by y minus m1 x1 mod divided by square root of 1 plus m1 square. This is the length of the perpendicular, and the length of perpendicular to the second line, it is y1 minus m2 x1. This is from the point x1 y1 divided by square root of 1 plus m2 square, and it is given that we have to find the product of the length of the perpendiculars. So if we multiply both these terms, the answer we will get, it is mod of y1 minus m1 x1 mod of y1 minus m2 x1 divided by square root of 1 plus m1 square square root of 1 plus m2 square. So when you multiply these terms, you will obtain the equation in this form. These calculations, these are shown over here. you will obtain the answer in this form. And when you adjust the terms, you are getting the answer in this form. And when you adjust all these terms, you will obtain that this is the equation in the form. It is ax1 square plus 2hx1 y1 plus by1 square divided by square root of a minus b square plus 4h square. We have substituted the values of m1 plus m2, m1 into m2 in these equations, and we obtain the final answer in this form. Now next we have is show that the area of the triangle formed by the lines, there are two lines whose combined equation is this, and there is another line lx plus my plus n is equal to 0. So the two lines we are talking over here, suppose they are of the form y is equal to m1x and second it is y is equal to m2x. So we have over here that m1 plus m2 that is equal to minus 2h by b, and m1 into m2 is equal to a by b. Now we are talking about the coordinates of a and b. We are talking about the coordinates of these 2 points. So the intersection of these 2 lines we are considering to calculate the coordinates of the point A. We calculate the intersection of these two. It is minus n by L plus m into m1, and it is minus n m1 by L plus m into m1. These are the coordinates of the point A, and the coordinates of the point B, they are given by the intersection of these 2 lines, and the coordinates of the point B, they are given by this equation. So we have 3 points over here. One is the point 0 0, second is, these are the coordinates of the point A, and these are the coordinates of the point B that we have. So if we want to calculate the area of the triangle with these coordinates, we obtain the answer as 1 by 2 mod of minus n by L plus m into m1 into minus n m2 by L plus m into m2 minus n by L plus m into m2 into minus n m1 by L plus m into m1 and mod of this value. And when we solve these terms, these calculations, these are shown over here. You can look at these calculations over here, and you can substitute the value of m1 plus m2. We have, these are the values of m1 plus m2 and m1 into m2. We substitute in these equations, and the answer we obtain, the final answer we obtain, it is in this form. So this is the area of the triangle formed by the 3 lines. 2 lines, they are given by this joint equation, and 1 line it is given by this equation. Next we have is angle between the pair of lines ax square plus 2hxy plus by square is equal to 0. So again, clearly both the lines corresponding to this joint equation, we are having the equation y is equal to m1x, second is y is equal to m2x. Both these lines, they will pass through the origin, and the value of m1 plus m2 we will have, it is minus 2h by b, and the value of m1 into m2 we will have, that is equal to a by b. If theta is the angle between these two, then we have tan theta, that is given by mod of m1 minus m2 divided by 1 plus m1 m2. So we can write the value of m1 minus m2 and m1 into m2. We can substitute these values in this equation, and we will obtain that the value of theta that we will have, it is tan inverse 2 square root of h square minus ab divided by mod of a plus b. And similarly, we can also show that the value of sin theta that we will have, in place of tan theta, if we calculate the angle in terms of sin, we will obtain the answer in this form. So we are saying that the lines represented by these two equations, The joint equation is given to us, ax square plus 2hxy plus by square is equal to 0. The two lines, they will be perpendicular if and only if a plus b is equal to 0. We are talking about this condition over here. These two lines will be perpendicular if the denominator is 0. So we are saying that the coefficient of x square plus y square is equal to 0. If the coefficient of x square plus y square it is 0, then we are saying that these two lines will be perpendicular to each other. Next is pair of lines perpendicular to the lines represented by ax square plus 2hxy plus by square is equal to 0 and passing through the origin. We have to calculate the pair of perpendicular lines. So again we are considering that the two lines corresponding to this equation, this joint equation, they are y is equal to m1x and second is y is equal to m2x, where m1 plus m2 it is given by minus 2h by b and m1 into m2 is equal to given by a by b. So we are saying the lines perpendicular to y is equal to m1x and y is equal to m2x. The line that is perpendicular to this line, that its equation will be y is equal to minus 1 by m1x, and the line which is perpendicular to the second line, its equation is y is equal to minus of 1 by m2x. So if we write the combined equation, we obtain it is y plus 1 by or x by m1 into y plus x by m2, that is equal to 0. If you multiply these terms, we will obtain it is m1 y plus x into m2 y plus x, that is equal to 0. Multiplying all these terms, we will obtain the equation in this form, and final equation that we will obtain, it is bx square minus 2hxy plus ay square is equal to 0. So we are saying that the pair of lines perpendicular to this given system or given pair of lines, it is given by bx square minus 2hxy plus ay square is equal to 0. Next we have is condition for the lines to be coincident. So again we are considering the two lines, y is equal to m1x, second is y is equal to m2x. These are corresponding to the joint equation, and we are saying that both these lines will be coincident if the angle between them either it is 0 degree or it is pi. It means that tan theta should be equal to 0, and this implies us that h square should be equal to ab. So we are saying that the lines represented by ax square plus 2hxy plus by square is equal to 0 are coincident if and only if h square is equal to ab. That is, we are talking about this equation ax square plus 2hxy plus by. This is a perfect square. Next is show that the straight lines x square plus 4xy plus y square is equal to 0 and x minus y is equal to 4 form an equilateral triangle. So we calculate the equation, the two equation of the lines corresponding to this equation, the slope of these two lines. We have the value of the slope of this line. So from these three slopes we will prove that the angle between all these three lines, it is 60 degree, and we will be able to show that it is an equilateral triangle. So clearly this is an homogeneous equation of second degree. So it will represent two lines which are passing through the origin. It will represent two lines which are passing through the origin. And second equation, it is given by x minus y is equal to 4. We are saying this is the line x minus y is equal to 4. So from this first equation we can write it is x square plus 4xy plus y square is equal to 0. We can write this is equal to 1 plus 4 into y by x plus y by x square, that is equal to 0. If we substitute y by x is equal to m, or we are solving for y by x, we obtain y by x is equal to minus 2 plus minus root 3. So the two lines we have, one is y is equal to minus 2 plus root 3 times x. Second is y is equal to minus 2 minus root 3 times x. These are the two equations of the lines that we have. Now if we calculate the slope of these lines, the slope of the line PQ, the slope of this line PQ, we have it is 1. The slope of this line we are talking about, this line is over here, and this is the equation of this line over here, and their corresponding slope of this line, it is given by, it is square root 3 over here, it is minus root 2 minus root 3, and slope of this line, it is minus 2 plus root. Now we are going to calculate the angle between these lines. So if we calculate the angle between these two lines, we know that the formula we have, it is tan theta, that will be 2 times square root of 4 minus 1 divided by 2. So the answer we are getting, it is equal to square root 3. The value we are getting, it is square root 3. So this gives us that the value of theta we have, it is 60 degree. Similarly, if we calculate the value of angle between the line given by the slope, we have m is equal to 1, and the slope we are considering, say this is m2 is equal to this. We are calculating the slope using these two slopes. We are calculating the angle over here. The answer we obtain, again the angle we have, it is 60 degree. So we are saying that this angle we have, it is 60 degree. The angle between these two lines, it is 60 degree. This is a triangle, so this angle is also 60 degree. So using all these three angles, we obtain that the final angle, this triangle that we have, it is an equilateral triangle. Next we have is bisector of angles between the lines given by homogeneous equation. So we are talking about the case that a homogeneous equation of degree 2, ax square plus 2hxy plus by square is equal to 0. This equation is given. We know that these are two lines which are passing through the origin. We are supposing their y is equal to m1x, and second is y is equal to m2x. These are the two lines we are talking about, and we are talking about this is the joint equation of these two lines. We are talking about the angle bisector of these two lines. We have to calculate the angle bisector. The condition we have over here is m1 plus m2, that is equal to minus 2h by b, and m1 into m2, that is equal to a by b. These are the two conditions that we have over here. So suppose we are saying, we are talking about, this figure is already shown over here. We are saying these are the two lines we are talking about. Suppose there is a point P over here. This is PXY, which lies on the angle bisector of these two lines. The slope of this line, it is m2, slope of this line, it is m1. So this is the point O that we have. Now if we draw the perpendicular from P on these two lines, we are drawing the two perpendiculars over here. We are saying that this point, say this point, it is N, and this point is M. This is PM and PN, these are the perpendiculars. And if this is the angle bisector, we know that the length of PM should be equal to length of PN. Now we have this point XY. We know the equation of these two lines. So distance of the point P from these two lines, it is given by mod of K minus M1H divided by square root of 1 plus M1 square, mod of this value, and that should be equal to K minus M2H divided by 1 plus M2 square, and mod of this square root of this value, and the mod of whole of this value. So on solving this, we obtain the condition in this form. So we are saying the locus of the point PHK, it is given by this equation. We are talking about this equation. It gives us the locus of the point PHK. So these are the two equations we have. So if we have a combined equation over here, why we are having two equations? because we are talking about two lines over here. One is the line that we have, we are talking about these are our axes. We are talking about these two lines that we have. So these are the two lines we are talking about. So we can have two angle bisector. One is the angle bisector of this line and one is the angle bisector over here. Both of these, this is the angle bisector of this portion and this is the angle bisector of this portion. Now if we write the combined equation of both these lines, it is y minus m1x over square root of 1 plus m1 square plus y minus m2x over square root of 1 plus m2 square into y minus m1x over square root of 1 plus m1 square minus y minus m2x over square root of 1 plus m2 square, and this value is equal to 0. So when we take the product of these two terms, these calculations, these are shown over here. This is the combined equation of both these lines. So when you solve these equations, you will obtain the final answer in this form, that is x square minus y square over a minus b is equal to xy over h. So this is the combined equation of the two angle bisectors. So based upon this, we have the following problem. First is, find the equation of the bisector of the angle between the lines represented by, this equation is given to us. So if we compare the coefficients over here, the value of a we have it is 3, the value of h we have it is minus 5 by 2, and the value of b we have it is equal to 4. So we are saying that by substituting the value in this previous equation, we obtain it is x square minus y square over 3 minus 4, that is equal to xy over minus 5 by 2. And on solving this, the combined equation of angle bisectors, it is 5x square minus 2xy minus 5y square is equal to 0. Next is, show that the line y is equal to mx bisects the angle between the lines. This line is given to us, and this condition we have to prove. So if we look at this equation and compare the coefficients, so we have this is a over here, then we have over here it is minus 2h and this is b. So if we write the equations of the angle bisector over here, we will get it is x square minus y square over a minus b, that is equal to xy over minus h. Now by writing this equation in this form, we obtain it is minus h into x square minus y square is equal to a minus b into xy. Now it is being given that the line y is equal to mx is the one of the angle bisector. It means that this equation should satisfy this result. We are saying that this is the combined equation of two lines, one of which is this line. It means this line should satisfy this equation. So in place of y, we substitute this value. In this equation, in place of y, we are substituting this value, and we obtain it is minus h into x square minus m square into x square, that is equal to a minus b into x into mx. So if we take x square common, we obtain it is minus h x square into 1 minus m square, that is equal to a minus b x square m. This x square gets cancelled. We are taking that x is not equal to 0. This is variable over here. So on solving this, we obtain the required condition. It is h into 1 minus m square plus m into a minus b, that is equal to 0. And this is what we have to prove. This is the required condition that we have to prove. Next we have is, if pairs of straight lines, these are the two pairs given to us. This is one pair of straight lines and this is another pair of straight lines, be such that each pair bisects the angle between the other pair, then we have to prove that p into q is equal to minus 1. Now corresponding to this first joint equation, if we write the bisector, the equation of the bisector, then we will have the equation is, it is x square minus y square divided by 1 minus minus 1, that is equal to xy over minus p. So this implies us that minus px square minus 2xy plus py square is equal to 0, and it is being given that this equation and the second equation, they are same because one pair of line is the angle bisector of the other. This is the angle bisector of this first line, and this correspond to the second equation. So if both these equations, I am talking about this second equation, it is x square minus 2pxy minus y square is equal to 0. So if both these equations, these are same, it means we will have 1 over minus p, that is equal to minus 2q over minus 2, that is equal to minus 1 over p, and this implies us that pq is equal to minus 1, and this is the condition that we have to prove. Next is prove that the angle between one of the lines given by ax square plus 2hxy plus by square is equal to 0, and one of the lines given by this equation is equal to the angle between the other two lines of the system. So if we talk about this first equation, the angle bisector that we will have, that will be, the equation will be x square minus y square over a minus b is equal to xy over h. And if we look at this second equation, it is of the form ax square plus 2hxy plus lambda times x square plus y square is equal to 0. So if we combine these terms, it is a plus lambda times x square plus 2hxy plus lambda times y square is equal to 0. So from this we can write the equation of the angle bisectors as x square minus y square over a plus lambda minus b plus lambda is equal to xy over h, and this implies us x square minus y square over a minus b is equal to xy over h. So this is the equation of angle bisector of this line, and this is the equation of the angle bisector of the first line. And clearly we can see that both these equations are same. Both these equations we are talking about, this is the angle bisector of the first pair, this is the equation of angle bisector of the second pair, and we are saying both these equations, they are same. So this thing proves that we are talking about that we have two pairs of lines. One pair, suppose we are saying it is in this form. The second pair of lines, suppose it is in this form. Now if we talk about the angle bisector of these lines, we are saying this is one angle bisector of these two lines, and this is the angle bisector of these two lines, and both these lines, these two lines we are talking about, these are same, these are the angle bisector of these lines. So what we obtain is the angle bisectors are same. It means that one line, this one line we are talking about, given by one pair of equations, that makes the equal angle with the line from the second pair, and this is what we have to prove. So we are saying, as we have proved that both the angle bisector, they are same, so this completes the proof of this question. Next question, we have to show that the pair of lines given by, these are the two equations given to us, this is one pair of lines and this is another pair of lines. We have to prove that both these lines, these are equally inclined to each other. So this is similar kind of question. So we are writing, these are the two equations that are given to us, and if we write the equation of the bisector corresponding to both these lines, we will obtain that they have the same angle bisector. So we are considering the line one, we are considering, I am talking about this image over here, it is P dash O P. We are talking about this line P dash O P, and another line we are talking about, it is Q dash O Q. This is one pair of line we are talking about. Suppose this is one pair, and another pair we are saying it is R dash O R, and this pair we have, it is S dash O S. These are the two pair of lines we are saying, and the equation of the angle bisector we have over here, it is A dash O. This is the equation of the angle bisector that we have. Now we have to prove that both these lines, these are equally inclined to each other. So look at this angle over here. Suppose this angle we are saying, this angle, suppose this we are saying this is A, and measure of this angle it is B. Similarly, measure of this angle is A, it is angle bisector over here, and measure of this angle it is B. So what we obtain is that this angle we have it is A minus B. Similarly, this angle we have it is A minus B. So both these angles, these are equal to each other, and this is what we have to prove. This is the result that we have to prove. Now next we have is, if the lines represented by, these are the equations given to us, one is x square minus 2pxy minus y square is equal to 0, are rotated about the origin through an angle theta, one in clockwise direction and other in anti-clockwise direction, then find the equation of the bisector of angle between the lines in the new position. So we are saying, since this line we are talking about x square minus 2pxy minus y square is equal to 1. If we look at this equation, the coefficient of x we have it is 1, the coefficient over here it is minus 1, and sum of both these values it is 0. So clearly both these lines, these are perpendicular to each other. Now suppose that the lines we are talking over here, the pairs we are saying, one is this line OC, and corresponding to this the line we have it is OD. The second pair we are talking about it is OA and OB. These are the two pairs we are talking about, and their bisectors, when we are saying the bisector we have it is this OE is the angle bisector and OF is the angle bisector. This is the pair of the angle bisectors that we have. Now if we look at the angles over here, we are talking about say the angle COE. We are talking about this angle, this complete angle COE, and we are talking about the angle DOE. We are talking about the angle DOE. E is the angle bisector, so both these angles, these are equal to each other. Similarly, when we are talking about the angle COA, we are saying this is the angle COA we have, and this is the angle DOB that we have. These two angles we are talking about. Both these angles, these are equal to each other. It is being given in the question. Now if we subtract these values, we obtain that angle AOE, we are talking about the angle AOE, that is equal to angle BOE, that both these angles, these are equal to each other. So what we can say from this is that the bisector of the angle between the lines in a new position, from this result we can clearly see that the angle between the lines, the bisector of angle between the lines in the new position is same as the bisector of the angle between their old positions. So it means if we have to calculate the equation of the bisectors in the new position, we have to calculate the equation of the bisector of this given line, and the equation of the bisector of this given line, it is given by x square minus y square over 1 minus 1 is equal to xy over minus p. So the equation we obtain it is px square plus 2xy minus py square is equal to 0. So this is the required equation of the bisector of this angle.